Now, everything here on page 35 is really just highlighting the steps that we go through for what you were able to do on page 34. It's just the reasoning, going through the reasoning and reviewing. So everything on page 35 you already know, but I'll just go through and read through and make sure that we're on the same page in terms of being able to reason through and finding our values. Okay. So we know how to answer trig problems that use special angles. If we're trying to find sine of 315, we know that's in the fourth quadrant. And if we were to put 315 onto our graph, we know that just by virtue of the reference angle, 45 degrees, we know that is part of a 45-degree family, which means that our ordered pair, we know is going to be related to this, right? We know that first quadrant, pi over 4, is going to give us an x value of root 2 over 2 and y value root 2 over 2. But we know it's in the fourth quadrant, so we can make an adjustment. We know the x is positive, the y is negative. Sine is based on the y value. So therefore, our answer is going to be negative root 2 over 2. Right. Okay, for tangent of 7 pi over 6, we know that this is going to live in the third quadrant because if we just look at that fraction, right? That's a little bit over 6 over 6. You know, 6 over 6 is just 1 pi. So 7 over 6 is a little bit over 1 pi. So we know it's in the third quadrant. So third quadrant, we know, looking at that denominator, you know it's part of a pi over 6 family, which is 30 degrees, and you know the ordered pair is just going to be, well, in the first quadrant at least, is root 3 over 2 and 1/2. But because we're in the third quadrant, we know to make the adjustments, both my x and y values are negative. Okay. And then we look to see what tangent is going to be using those ordered pairs. We know tangent is y over x. So you can write it this way, but I think it's easier if you just cover up the denominators and just do y over x. So negative 1 over negative root 3. The negatives cancels out. So I'm left with 1 over root 3, but it's not rationalized, so I can rationalize it by multiplying numerator and denominator by root 3. I get root 3 over 3. Okay. All right, if the angle is bigger than 1 revolution around the circle, what we can do is we can work it down to a coterminal angle between 0 and 360, and then we'll have much better idea as to how to interpret. So take that 840, subtract 360, still outside of our range. So I'll take another subtraction of 360, and I get 120. So once I'm down to 120, I have a much better perspective. I know that's in the second quadrant, and if I just put that 120 there, I should be able to quickly identify this is part of a 60-degree angle family. So I know that 180 minus 120, my reference angle is 60. So if it's 60, I know my ordered pair is going to be 1/2 root 3 over 2. Second quadrant, I know it's negative positive. And so therefore, I'm targeting cosine, which is the x value. So the cosine is simply negative 1/2. If the angle is negative, right, then what we can do is we can add 2 pi or 360, depending on which form is given, until we get to something that we recognize. So negative 4 pi over 3, I can add 2 pi to this. Or you can just think about the fraction, right? Negative 4 over 3 plus 2 is the same thing as negative 4 over 3 plus 6 over 3. And so that gives me negative 4 plus 6 is 2. So 2/3 pi, you know 2/3 pi is in the second quadrant. This is, again, part of a 60-degree family, a pi over 3 family. So you know it's 1/2 root 3 over 2. Second quadrant, we know that x is negative, y is positive. And now we go back and see cosecant. Cosecant is related to the y value But we know cosecant, we got to flip the sign around. So √3/2, if I flip that, I get 2/√3. But it's not rationalized, so if I multiply numerator and denominator by √3, I get 2√3/3. Right, so far so good, right? You guys, if you're able to do page 34, you're able to do all of this. Okay, now what's new is, what if the location is not on the unit circle? Meaning that, what if we're dealing with an angle that is not a special angle, okay, or not a variation of a special angle? Then we can simply rely on right triangle trig, Pythagorean theorem, to help us arrive at our value or at our ratio. But it's not difficult, but we do need to make sure that we are drawing our triangles correctly. Okay, that's the biggest thing. So number 5, it says, find the secant of theta where the terminal side passes through -5/7. So what we're going to do is we're going to start at 0, 0, and we're going to identify the order pair -5/7, understand that's in the second quadrant, and then we're going to just see if we can make our path towards that order pair. So I have to go -5 over to the left. I have to go up 7 units. And it's important, okay, it's important that the distance from the origin to the order pair is your hypotenuse. And it's also important that you draw your triangle involving only the x-axis and not the y-axis. Okay, so you don't want to draw it this way, you don't want to draw it this way. This just messes everything up. So make sure that whatever you do with your triangle, make sure that one of your sides involves the x-axis, okay, and never the y-axis. Okay, the angle is always the one that is stemming from the origin, so that theta is always here. We never want to put theta anywhere else. Okay, so first things first, we need to make sure that we can draw our triangles correctly. Okay, there's my right angle. All right, so that's the hard part. Okay, everything else is going to feel a little bit easier. The next part is we need to find hypotenuse. So how can I find hypotenuse given two sides? Right. Yeah, Pythagorean theorem, right? We have a right triangle. A squared plus b squared equals c squared. Okay. The second diagram kind of moves us along to the next step. If I solve for c, I get c equals c squared equals 74. So I get c equals √74. So now that I have the hypotenuse, I can now find secant of theta. So secant of theta is just hypotenuse over adjacent. No need to rationalize denominator. It's already, radical is already up in the numerator. But it's important that we are keeping track of the correct signs as we move across, right? So wherever you apply your order pair, just count and move left or right towards that order pair. And if you're moving down or to the left, make sure that you're making the appropriate negative or positive values. Okay, your hypotenuse is always positive. Okay, but your x or your y could be positive or negative depending on where you are on the coordinate plane. Okay. All right. Any questions here? Okay, so we're going to practice with this. Okay, practice with this here. All right, let's go to the next page. Let me just say this: 9 through 15 is not going to take a lot of space, but 5 and 7 does take some space. So if you want to put 5 here and 7 here, that's okay. But really, you're not going to need any space for 9 through 15. So just to kind of help you along, so you're not having to put everything difficult, in the small space here. So, but I'm going to put it on a different sheet just because it's easier for me to present it by playing in space. So here are the directions. It says the given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trig functions of theta. So first thing we do, make your coordinate plane and plot your order pair. Okay, doesn't have to be accurate. Just go ahead and plot your point and label it all negatively. So next step. Okay, you're going to start at your origin and you're going to move towards that order pair. So we're going to go right 1 and down 8. And then as you do that, go ahead and label whether your legs are positive or negative here. And make sure that your triangle does have is attached to the x-axis or is touching the x-axis. Okay, so all right, what's next?
You have to find the hypotenuse.
Hypotenuse, right? Pythagorean theorem. Go ahead and do that.
Square root of 60.
Yep. Let me show the work here. All right, use SOHCAHTOA and fill out your ratios for sine all the way to cotangent. If you're left with a radical in the denominator, make sure you rationalize it. We'll check our answers in a second, but if you're done, try number 7.
What angular part number?
Sine of theta will be negative 8 root 65 all over 65. We have to get that radical up to the numerator. Okay, check the rest of your trig ratios. Any questions? Okay, try number 7. Okay, number 7. Order pair is negative A15. So first thing you want to do is estimate where you think that order pair is, negative A15. You expect that to be in the second quadrant. Doesn't have to be accurate, just. And then start from your origin and then move towards that point in the horizontal and vertical way. So I'm going to go 8 units left, 15 units up. And we associate left with negative, right? And then up with positive. Okay, are we good with that? Right. And then your hypotenuse, right angle, theta. Okay. So that's probably the most important part. You need to be able to draw the diagram correctly. Otherwise, your signs could be off and everything could be off. So. Okay. Hypotenuse next. Again, your hypotenuse is always positive. I think that can be reduced further. Can we get that down to a whole number? 17. Okay, yeah. So you take the square root of that, should be 17. And then find your trig ratios for each of the functions. All right, check number 7. Any questions with that? Okay. All right, so let's explore 9 through 15 here. Does anybody still need to look at 7?
So why is it number 17 again?
The reason why it's number 17 is because we're doing SOHCAHTOA, so sine is going to be opposite of
Yeah.
So we want to make sure that we know where our angle is. We never want to put our angle up here, right? That'll throw everything off. Make sure that your angle is drawn closest to the origin. Yeah, so the diagram is the most important thing. If we can get that diagram down, everything should fall into place. Good. Any other questions with 7? All right, let's look at 9 through 15. So it says find the exact value of each trig function if defined. If not defined, then write undefined. Now these are all going to land on one of the axes, but we're just going to approach this the same way that we would drawing out just order pairs at those quadrants. So we know if we imagine this to be our unit circle, each of these order pairs are going to be 1 unit away from the origin, right? So we know that this order pair is 1, 0. This order pair is 0, 1. So sine of pi over 2 Where's pi over 2? Positive y-axis, right? And which value do we choose for sine? Y value. Okay, cotangent of negative 180. You can work that through. Negative 180 means I'm going clockwise, half a circle. That's going to take me to this, the negative x-axis. But you can also add 360 and convince yourself it's the same thing, right? So we know we're dealing with this order pair here. All right, how do we get to cotangent using our x and y value?
It's y over x.
Close.
Or x over y.
Yeah, so tangent is y over x, but cotangent is x over y. So let's do that. X over y. But how do we interpret this? Undefined. Good. 0 in the denominator means undefined. Okay, cosine of negative 270. Where is this angle located?
It's going to be 1, 0.
Well,
It's 0, negative 1, but it's going to...
Well, okay, so let's talk about this. Negative 270 means I'm going negative 270 in this direction. So I got to go 90, 180, 270. So I'm actually up here again. If you don't know where this is, add 360 to it, and that will get you to 90, right? So if you don't recognize an angle, you can always add or subtract 2 pi or 360 to get it into a range that you recognize. But if you feel like you can do this on your own, you can just kind of work your way around and realize, oh, that's going to be same as a 90 degree. Okay, so cosine, I know I'm dealing with this order pair. So what's cosine negative 270? Is it the x or y value? X value, so just 0. Okay, are we okay with there? Okay, tangent of pi, we know where pi is. Pi is in the negative x-axis. All right, how do we interpret tangent using x?
0 over 1.
Good, so
just 0.
Good, so now it's y over x, so 0 over negative 1, which is 0. Okay. Sketch each angle, then find its reference angle. So we're basically just going to draw the angle and look at that distance between that coterminal side and the 180 or 360 degree line, and find the reference angle. All right, so I'll do 17 here. I think I have enough space where I'm just going to split this up into 4 regions and draw my graph in each region. So 135, no need to be super accurate, but we do know where's it located. Which quadrant? Second quadrant. So okay, we're going to just identify how we reach that angle. And then it says find the reference angle. So reference angle is here. And what's this angle measure here? So how do I find my reference angle? Good, right? So all we do is we involve the 180 degree and find that difference. So we want to present our reference angle in the same form that is given in the problem. So 17, we're given degrees. We'll provide our answer in degrees. For 19, our measure is given in radians, so we'll present our reference angle in radians as well. Okay, so 7 pi over 12, where is that located? Which quadrant?
Second.
Good, yeah, so you know that if you look at that fraction, 7 over 12, that's a little bit more than 6 over 12. You know 6 over 12 is 1/2, so 1/2 is here. 1 is here. It's between 1/2 and 1, so must be in the second quadrant. So I'm going to identify my initial side to my terminal side. I know my reference angle is sitting here in this location. So how do I find my reference angle here? Subtract from pi, yep. So if you don't want to deal with pi, just think in terms of a fraction, right? This is 1 minus 7 over 12. So find common denominators there. So 12 over 12 minus 7 over 12 equals 5 over 12. There we go. So hopefully we're at a point where we're not having to convert between degrees and radians. It's just a lot faster if we can kind of just work in terms of radians and just understand our fractions. Okay, 21. Negative 405 degrees. We may not know exactly where that is, but we can just do what to help us get a better idea. At 360, right? So if I do negative 405 plus 360, I get negative 45. So you can add 360 again, but I think we have an idea where negative 45 is, right? If this is 0, if this is negative 90, we know negative 45 is going to be somewhere in that fourth quadrant. So I want us to draw our pathway to negative 405. So we're going to go in negative direction. We're going to start on our initial side. We're going to have to go a full 360 and then a little bit more 45 degrees as well. So we'll go a full 360. And then we'll go a little bit more, negative 45. But ultimately, we know that this is 315. We know we're going negative 45, so that kind of gives it away, right? We know our reference angle must be. Okay, try 23. Got it. Okay. We want to find that difference from 5 pi over 6 to pi. That's how we find our reference angle. So 1 minus 5/6. That means 6 over 6 minus 5 over 6 equals 1 over 6 pi over 6. Okay. The bottom half of 37 is just review. So cosine of 4 pi over 3. Imagine what you did yesterday, but without all the prompts. Right. So basically, we want to get directly to sine or trig of a special angle without all the prompting of all the information. So we'll see if we can do some of this here. So I'll start us off. Cosine of 4 pi over 3. I know this is in the pi over 3 family. I know my order pair is going to have these numeric values. But if I'm in a third quadrant, I know my order pairs are both going to be negative. I know my cosine is the x value, so therefore answer is negative 1/2. Okay, go ahead and try the rest of this page. Your homework is just the rest of page 37 and 38, just a few problems. So I'll give you guys 5 minutes to see how much you can do, and then we'll get ready for our practice practice unit circle. Check your answers.